seventh graders. We are going to be talking about the real number system. And so I'm going to go through our different number sets, and then we'll talk about absolute value and opposites as well. Okay, so first of all, we have our natural numbers. Our natural numbers are counting numbers. So when you think back to when you were itty bitty and you first started counting 1, 2, 3, 4, 5, and so on, those are called your natural numbers. So your counting numbers are the natural numbers. Here we have a couple of examples. But notice we have like a fraction here, so that 10 halves. The reason that that's in that natural number category is because if you simplify that, 10 halves would have the same value as 5, and so then that becomes a natural number. Our whole numbers are going to be all of our natural numbers plus 0. Okay, so those 1, 2, 3, 4, 5, but now we're going to include the number 0. So 0 is the main difference between the whole numbers and the natural numbers. These three values here, the 805, the 65, the 1564, those are also whole numbers, but more specifically, they would actually be natural numbers. Okay, so all natural numbers are whole numbers automatically. Integers are going to be whole numbers and their opposites. And this is what our main focus will be when we talk about this first unit will be over integers. And so we're mainly going to be focusing on these whole numbers and their opposites. So all of our whole numbers, okay, which also include those natural numbers, our whole numbers and our natural numbers are all automatically integers, but now we're also talking about their opposites. And so when I say opposite, that means on the opposite side of the number line, the same distance from 0, but on the opposite side. So all of these whole numbers are going to be integers. So 6 is an integer, 15 is an integer, 0 is an integer, but now also their opposites. So like -6, -15, -52, -256, -458. Again, this example here, 3,680. Technically that's an integer, but its most specific category would be a natural number. And then our rational numbers are any number that can be written as, in the form A over B, where B does not equal 0. This is just a fancy way of saying that you can write it as a fraction. So this will include two different types of, it's going to include your fractions and mixed numbers, positive, negative. It's also going to include what we call terminating decimals, which are decimals that end, and repeating decimals, which are decimals that never end but repeat in a pattern. So, for example, the 7.16 repeating, all right, that's going to be a rational number. If it's a terminating decimal, -1.85, that would be a rational number. And then also included are all of these other categories. The natural numbers, whole numbers, integers are all automatically rational numbers. The other category we have here are irrational numbers. So these are numbers that cannot be written in the form A over B. The main thing, these are going to be non-repeating, non-terminating decimals. And this will also include what we call imperfect squares, which you don't, non-perfect squares, which you don't really need to know a whole lot about right now, but so non-repeating, non-terminating decimals are decimals that never end or repeat. So 3.1214 something, 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 there's never a pattern that repeats. A repeating decimal could be something like 0.3 repeating, and a terminating decimal would be something that stops, like 1.25. I'm going to actually skip that part and come back to it here in a moment. So here for classifying numbers, again, it's going to belong in every category above the most specific category. So when I look at 2039, 2039 is going to be a natural number. it's also automatically then a whole number, which also automatically makes it an integer, which also automatically makes it a rational number. If I see a decimal like 7.8, 7.8, that's a terminating decimal, so that's a rational number, all right? However, it's not going to fit in these integer, whole number, natural number categories. -1/4 is a rational number. Square root of 30, that's a non-perfect square, so that's irrational. 76%, that would be equivalent to 76 hundredths. Okay, so that's a rational number, but again, not an integer, whole number, natural. Here, 1.276, dot, dot, dot. There's no pattern. It's not repeating. It's irrational. 15/3. If we simplify 15/3, we get 5. So 5 is natural, whole, integer, rational. 6.5 repeating. That's just going to be a rational number. And 0 is a whole number. Okay, not natural, integer, and rational. When we look at these statements over here, if they're always, sometimes, or never true, rational numbers are irrational numbers. That'll never be true. Integers are whole numbers. Sometimes they are. Okay, so you might have some, if I said 5, +5 is an integer and it's also a whole number. But if I said -5, -5 is only an integer and not a whole number. Whole numbers are natural. That's going to be sometimes as well. Really the only difference there is going to be that 0. Irrational numbers are integers, that's never. And natural numbers are integers, always. So every natural number is going to be considered an integer as well. All right, now we're going to talk about absolute value and opposites a little bit. So absolute value, actually I'll talk about opposite first. Opposite means the same distance a number is from 0, but on the opposite side of 0. So I think a lot of students would be able to tell me like the opposite of 5 is -5. The opposite of -3 is +3. So they're the same distance from 0, but on different ends of 0. Absolute value is going to be the distance a number it is from 0, okay? And so here we actually have some mistakes. So there's 4 main ideas here, or 4 problems, and each one of them has a mistake. So we're going to go through and find those mistakes. So here it says absolute value is the distance a number is from 0. That is true. All right. And then it says it will always be the opposite of the integer. So that is not true. So I'm going to actually cross that out, okay? Because it won't be the opposite. The absolute value is always going to be positive. So, for example, the absolute value of -5. -5 is 5 steps away from 0. Okay, that's how far it is from 0. If I said the absolute value of +5 is also 5 steps from 0. All right, so down here, these straight brackets, these are the absolute value. This is the absolute value symbol. So this is read as the absolute value of 3, and here it says the absolute value is equal to -3. These, again, have mistakes. So the absolute value of 3 is actually 3 units away from 0. This next one, we have this negative outside of the absolute value. So this is actually kind of read as the opposite of the absolute value of -8. So the absolute value of -8 is 8, but the opposite of 8 is -8. So that expression, because that negative is on the outside of the absolute value, it's actually going to be equal to -8. And here we have -4 is less than -9. So -4 is actually further to the right on the number line, so -4 is greater than -9. Now I'm going to come back down here. It says the number's opposite is a number on the opposite side of 0 with a different absolute value. All right, again, these have mistakes in them. So an opposite, it's going to have the same absolute value. So on different opposite sides of 0, but the same absolute value. A number and its additive inverse will have a sum of 0, which means they form a 0 pair. That one is actually true, as is. So what that means is something like 5, and then additive inverse is going to be a fancy way of saying opposite. So if I said 5 plus -5, that's going to have a sum of 0. Okay, these will, the number in its opposite or a number in its additive inverse form a 0 pair. And then down here, the values are ordered from least to greatest. So if we look here, I have the absolute value of -43, that's 43. The absolute value of 25 is 25. Absolute value of -16 is 16. Here I just have -16, and here I have 10. So these are not in the correct order right now. So if I were to order them correctly, we'd start with that -16, then the 10, then the absolute value of -16, the absolute value of 25, and the absolute value of -43. All right. So that kind of concludes some of our information about the real number system and those integers, opposites, and absolute value. Have a great day.